Well, hello YouTubers, electronics geeks, retro computer nerds. Welcome back to my channel. Mike here. Time for another odds and ends from my messy Workbench video. Going to talk about a couple things today that might be of interest to you. A while back I put out another video on the Teletext System Master and the daughter board that I had built and installed on it. Notice the daughter board is no longer on it because it was definitely a case of be careful what you wish for. Yes, I got it working, but there were side effects. There were unintended side effects, and they really limited the usability of the computer. So the daughter board's back off. We've just got the EEPROM, the 2K EEPROM chip back in it. Everything's back the way it was, and as soon as I did that, guess what? I figured out how to make the daughter board work the way I wanted it to. Isn't that the way it always goes? After I ripped the thing off. But that's okay because I would have to do a lot of major rewiring to this to get it to work the way I want it to. So the main problem, and I'll talk about this in more depth in the next Teletext System Master episode, this old computer episode. I'm just going to touch on it here. The main problem is this can only handle 2K of ROM in its standard configuration. I can cut some traces and add some bodge wires and get it up to 4K, maybe even 8K, but that's it. But I need 16K for what I want to do, and there's just no way to do that. I thought I had figured out a way with the daughter board to get around that, but it caused conflicts. Anytime it tried to address more memory than it thought was on the board, it would enable the bus buffers to bring data in from outside because it thought we were addressing data off the board. That's just the way it's designed. It's got half a dozen PAL chips on it that do address decoding and enable the buffers, and it's very opaque. There's not much I can do to prevent that. You know, it's all in the PAL code somewhere. So, yeah, we're back to 2K. But, you know, I was thinking about it the other day. I have great ideas in the shower. I was thinking about this not too long after I ripped the daughter board off when I was in the shower, and I thought, wouldn't it be great if I could just put like a 16 or 32K ROM in here, like I had. You know, I had a 27C60, I had a 28C64 in here that's 32K by 8. I said, wouldn't it be great if I could put that in here and only address 2K of it, but output the upper address lines on an I/O port and change which 2K window I'm looking at through that EEPROM. And I thought, well, yeah, that would work great. And guess what? I've got two parallel I/O ports right here. I mean, one I send status bits out to as the thing's booting up, so I know at what stage it is in the boot up sequence, and I can also just write random data out to it. But I've got an entire second port over here, second parallel port. It's got a Z80 PIO chip right here with two parallel I/O ports on it that are brought out on this header and this header right here. So what I could do is I could rework the daughter board so that lines from these headers go up to it. And then what I can do is I can write a program, put it in whatever 2K window is addressed when the thing boots up. And I believe these lines are all high on boot up, okay? So if I use them for the upper address bits, and I had like a 32K EEPROM in here, then on boot up, it's going to be looking at the upper 2K of that 32K EEPROM. That's fine. It can start running out of there just like it runs, you know, the monitor I've written for this to run out of the lower 2K of memory. It can run out of the upper 2K, that's fine. As far as the computer's still concerned, it's still running the lower 2K. It won't know that it's addressing the upper 2K of a 32K EEPROM. It won't know that. So I can write a minimal sort of bootloader in there. That what it'll do is it'll turn on the RAM down here, which is not enabled by default when the thing boots up. Turn on the RAM and copy a program, a small program, into RAM, and then jump to running that program. And what that program will do is it will initialize the parallel ports and send data out that will become the upper address lines on the EEPROM. And what we'll do is we'll start addressing 2K windows through the EEPROM and copying the data in those 2K windows into RAM. Okay? And then once we've got everything in the EEPROM copied into RAM, we can just turn off the EEPROM access. There's a way to do that on this board so that it stops sending chip enable signals to the EEPROM. And then we'll just run out of RAM. Everything will run out of RAM. So I'll copy, my initial plan is to have 16K, or the lower, well, a lower or upper, it doesn't really matter, but half of the 28C256 will have the software in it I need to run. So that's 16K. So we'll copy all that into the lower 16K of RAM. We'll disable the EEPROM, and then we'll jump into the bottom of the program and finish the actual boot up sequence of the monitor. So yeah, I thought about all that and I said, wow, that's semi-brilliant, Michael. Why didn't you think of that the first time rather than the workaround you tried before that didn't work? So yeah, so that's one possible way to go. Like I said, I figured out how to do it. I haven't decided yet whether I want to do it. I figured out how to do it though. So that's interesting. So may end up modifying the daughter board down the road. I may actually have to build another one because I had to cut a lot of the header pins for the EEPROM because there were signal conflicts between the EEPROM it expects to be in there and the EEPROM I was running, so they don't have the exact same pin out. I'll have to see if I can make this work or if I have to start over from scratch. So that's a possibility. Just yeah, I can make that work, I think, because I thought I could make it work the other way. So there may be some hidden gotcha I'm not seeing, but I don't think there is, because we'll never be able trying to address more than the lower 2K of memory on this thing as far as the computer is concerned. It won't know that every time we twiddle bits to the I/O port that we're changing address lines to the EEPROM and looking at another 2K window up, 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 up through all those available 32K on that EEPROM, or in my case I'll only be using about 16K of it. So as far as I can see, it ought to work. So we'll see if I go that route. It may be a little while before I start working on that project because I've got some other stuff coming up that's going to keep me really busy for about the next month and a half. So next on the agenda, sooner or later, once I get this thing working to my satisfaction, I'm going to want an enclosure for it. And, you know, a backplane, a real backplane. So, you know, I've got my S100 backplane here that I bought, my Jade backplane. I've got my prototyping cards here that I bought, and I've been looking at power options. So in the last odds and ends for my Workbench video, I showed you this, which is a buck converter. And what this does is it'll take in any voltage, pretty much any voltage you want to give it, and output a voltage as long as it's lower at a pretty decent current. So I could put 12 volts into this from, say, a PC power supply, an ATX supply or whatever, and I can get 8 volts out. And I can use that to provide power for these S100 cards. Okay, so, that part is solved. I've got the 8 volt power supply. Okay. So I should be able to power unmodified cards in this bus, like the System Master, which is unmodified. It still has its voltage regulator on it. It needs 8 volts input. So I could run other S100 cards unmodified in here too with this. Then I found this. This is another little DC-DC converter. It has, this one's adjustable, and I can adjust it to whatever I want. I've adjusted it to 8 volts. This one is fixed at plus and minus 15. And this can handle just about any kind of input voltage you want to throw at it. And what you'll get out is plus and minus 15. So that would take care of the plus and minus 16 volt rails that this thing expects to see. It's going to be a volt low, but I think it's going to be fine. I think the regulators can handle a volt low to give plus and minus 12 volts where it's needed. Minus, on odd occasions, minus 5 volts. So I think we're good with that. So again, this can be powered with like an ATX power supply. So I can use a regular modern computer power supply, run the power through these two modules here, and then I'll get the voltages I need to run an S100 system. Okay, so it's just a matter of mounting these somewhere inside the box, and we'll talk more about the box in a bit. Then I got to thinking, well, I've got these prototyping boards. Why don't I just mount them on the prototyping board? So one of these boards could have, you know, the power modules mounted on it, and there's still room for other stuff. I could put in the address decoding chips, and I'd have room for some EEPROMs or some other logic that I might need over here, some I/O ports, something. Plenty of room left over. So yeah, I think mounting these on one of these boards is the best option. Then I could just plug the board in the bus, and the board can power the bus. And maybe I'll put Molex connectors up here, like on the top of one of these cards or on the side of one of these cards, might make more sense, and plug like a drive cable from an ATX power supply in it to supply voltage to the board. This can regulate it, this can regulate it, and then this can out along the bus to supply everything else. So that's what I'm thinking. I might do that. So I talked about box. Well, I need a box to put all this in. So I've got a couple of possibilities. You know, over on my main channel, I'm always scrapping out computers. In fact, I recently got a huge Gaylord full of old computers from a mega corporation that I handle their e-waste, basically. So there were some older PCs in there, and one of them, I saved the case from it. You know, I scrap out the motherboards, the hard drives, the RAM, all the good stuff, the power supplies. I saved the one case in power supply because it was a very large case. I'll give you a picture of it. Of course, you can't really tell much scale from the picture, but it's plenty big enough I can get this board inside it. And without modification, I could easily use over half of the slots. If I modify the internals of it a little bit, rip out some of the hard drive bays in there, the internal hard drive bays, I could easily access all except for maybe one slot. And if I was to cut one of these boards a little narrower, I could use all of them. So that's a possibility. It's a simple solution. It's already built. It's got an ATX power supply in it. It's ready to go. I could just bolt this in, and I'm going to have to add a couple extra fans. The airflow is not quite right for having you know, a bunch of boards in it that need to have airflow, you know, running across them this way. So it's more built to run that way, but I can put some more fans in it, redirect the airflow, open up some vents, and really it's a pretty easy solution to the problem. The main issue is it's just going to look like another PC. Aesthetics? Really? Do I want to get into aesthetics? So do I want to go that route, or do I want to build some nice handmade furniture grade wooden case with some nice blinking lights on the front, you know, and a big honking power switch, you know, like a lot of the early computers had? Do I want to go that route? Do I want to make it a little more distinctive, stand out a little out of the crowd a little bit, you know? That case in here, I have 1, 2, 3, 4 desktop computers in easy view of me right now where I'm sitting. It'll look like just another desktop computer, but if I build that nice handmade furniture grade wooden case, stain it, finish it, you know, a few blinking lights on the front, you know, that would really stand out of the crowd. So that's a possibility. What do you guys think? I'm throwing this out there asking your opinion. Which way should I go? So, not that you have veto power or anything, you know, but I would like to hear some opinions from my viewers. Which way I should go on that. And, you know, I could actually go with the PC case as an interim solution while I build the nicer case. So that's a possibility too. Just to get the thing up and running, because that would be pretty simple. I might have to 3D print some rails and brackets and card guides and bolt the thing into the PC case, but I can get that up and running pretty quickly, I think. And then while I, you know, in my spare time, do the carpentry and woodworking and the finishing and whatnot on the final case. So that's a thought. So yeah, leave your opinion in the comments, which way you think I ought to go. What you would like to see in your own office, which version you'd like to see. And then those of you who are eagerly awaiting part 2 of my repair on the Pioneer Spec 4 amplifier, part 2 of that is coming along. I don't want to give you too many spoilers, but let's just say there's going to be a part 3 because it ain't up and running yet. Got some issues. Getting parts is a big problem. A lot of the parts in that thing haven't been produced in 30 or 40 years, and finding new old stock is difficult, and sometimes it has to come from the other end of the planet, and there's shipping issues, there's a global pandemic. It's getting the parts is taking forever. So that's why part 2 hasn't come out yet, although it will be coming out soon. But there's going to be a part 3, but again, we may have to wait a while because parts, okay? Getting the parts. And hopefully part 3 will be the last part. We'll see. No promises though. Okay. And then one last item. Up on the main channel, you know, I recently did a pretty epic scrap pickup at a large corporation, and one thing I got was this oscilloscope, and it works. It's kind of a name I don't recognize, Iwatsu, but it works. It's just an old CRT model. It is in absolutely excellent condition. I don't think this thing has hardly even been used. It's probably 25, 30 years old, but it practically looks brand new. It works great. So this will be a nice addition to my workshop here. Yeah, so up until now, the only oscilloscope I've had is this Exitech digital LCD oscilloscope, which, don't get me wrong, it's a great oscilloscope. I won this actually for my entry in the 555 timer design contest 10 years ago, run by Jerry Ryan. And, you know, it's a great little oscilloscope. It served me well, but it does have its limits. And this one's got a few more options on it. And also it's easier to get to everything. I mean, this has most of the same functions on it available, but you got to go through a lot of menus to get to some of them, and it takes time, and you got to remember which menu to go through. Whereas here, everything's available at the push of a button or the turn of a dial, really quick and easy. So that's great. So this is going to be a great addition to the Workbench here. It's going to come in really handy. It'll probably appear in future videos, and I'll probably be using it on the Spec 4. Maybe in part 3. We'll see. So anyway, there you go. There's a little bit of an update and a little bit of this and that and odds and ends from my Workbench. So I hope you found this video at least a little bit interesting, educational, inspiring, killed a little time, whatever. Give it a thumbs up, give it a like, subscribe to see future videos. Check out my main channel, OmegaGeek64. Subscribe there. And press the little bell icon in both places to be notified when new videos come out. And thanks for watching. I'll see you in the next video. Bye.